an expert on physics as chief guest as Dr. Rajiv Singh, Assistant Professor, IIT BHU. Sir, we welcome all of you. We are grateful that you consented to be the part of this lecture series. And I request Honorable President Sir, the driving force of IHS, who is also the accelerator of IHS, who keep on pushing us for innovative ideas and bring them into reality. So I invite President Sir, first of all, to say a few words and consent us to proceed today's program.
Thank you. I want to be very brief and to the point. This is one of the clarion calls we had from the Prime Minister that we should be Atmanirbhar. You cannot be self-sufficient. India cannot be self-sufficient unless it produces a lot of entrepreneur jobs and comes up with new scientific research to solve the problems. We have two ways in our culture to find something new. One is that we do meditation, and in deep meditation, like Patanjali says, you can focus on an object and know intuitively what's going on in there. That's our ancient wisdom. But not all of us can do it. I want to tell you that we need scientific research to push ahead. Scientific research is something, it can be done, it takes a long time. But I want to quote you a biologist, James Watson. He died today. He had the Nobel Prize at age 24. 24. How many of you in the audience here are 24? He got a Nobel Prize. And how did he do it? Because he put together information and created what is known as double helix. The DNA sequence, which is like a twisted ladder. He gave us that helix. He gave us the DNA. And he was a guy born in Chicago, but he interpreted the data from London. So you don't have to find something new. You have to do two things. You have to join the two things known, and the third one will be created something new. So I just want to focus that the purpose of this series is to encourage our students. This will be later on put on the YouTube to encourage people who are listening to become scientists. We need more scientists. We cannot have just engineers, doctors, and collectors. That will not make us Atmanirbhar. So without further ado, I welcome Dr. Singh. Please help us understand this, because I'm a doctor, but a lot of people are in the audience here who don't have the science background. So what is the implication of this new research for a common man? So with that, I will stop here and invite Prashant Shukla to start his lecture.
Pranam sir, thank you sir for giving me this opportunity to represent this lecture series in front of all dignitaries and in front of Rajiv sir especially. As he belongs to the field of the topic directly. So without any delay, I would just start sharing my slides here, and this should help all of us to discuss it. Just a second. I hope these slides are visible.
Now they are. They are visible.
Thank you, sir. Uh, so this is today's theme, the Atmanirbhar Bharat lecture series 2025, and the sub-theme Nobel Prize in Physics 2024. This year, the Nobel Prize in Physics is awarded for the foundational discoveries and inventions that enable machine learning with artificial neural network. And as we all know, this the artificial neural network, artificial intelligence, and machine learning, these all are going to be the future of the world. Without the machine learning, the successful will not be possible. I think successful life will not be possible. In the next slide, it's we can see these are the two laureates. They shared the Nobel Prize for 2024 in physics. John J. Hopfield and Geoffrey Hinton. John Hopfield belongs to the Princeton University, USA. Geoffrey Hinton, he belongs to the University of Toronto, Canada. They combinedly suggested the concept of the modern artificial intelligence, artificial machine learning, based on the concepts, fundamental concepts, and fundamental concepts of physics. Here in the picture, it is a simple diagram. Here we can see a lady is trying to move from one step, means step by step she is trying to move to the different nodes, and these nodes are interconnected exactly as the atoms are interconnected. Hopfield suggested that the spin interaction between the atoms, the electrocovalent bonds, and the electrical forces acting between the atoms, these out of these, the connection between the atomic spin can help uh, to store the memories in the crystal. And here in this picture, this lady is free to move any of the, she is free to take any of the steps either forward or backwards. It is actually trying to show the combination of Hopfield network and the Boltzmann machine, along with that the restricted Boltzmann machine, which are the fundamental concepts of the two scientists enabling the machine, the concept of machine learning. Sorry, please do not change the slides. Okay. Huh. So next, with the help of this picture, I would just try to elaborate so that everyone can understand what is a Hopfield network suggested by John Hopfield. As you can see here, this musician is trying to play some music. If it is very easy to tell with this example that if a classical musician is given a cue, is given a node of or the starting of a music, he can play the complete, he can recall the complete music and he can play it with the instruments. And this he can play the music very easily, flawlessly. As you can see here in the picture, sorry, the last one. He can play the music flawlessly, but this musician cannot recall how the slides are getting changed automatically, sir. Ajay sir.
Sir, I don't know, but slide are continuously 4, 5 automatically change, sir.
No, you can stop that. You can change that. Don't tell me you cannot change it.
Yeah, I'm changing. So this musician can play by recalling the particular music very easily, but it cannot create the new one. As you can see, it cannot create the new pattern. As the next slide shows here, this slide shows here, in the Hopfield network, these you can see these noisy or partial cues, noisy patterns are shown 0, 1, 2, 3, 4, 5. These numbers are noisy in the first picture. Hopfield network, using the concept of the associative memory. It can recall these patterns clearly, and here in the second picture you can see the recalled memories means the clear pictures of these numbers 0, 1, 2, 3, 4 up to 9. These all are indicated, they are displayed. So basically, this Hopfield network helps to recall the memories which are already stored in the lattice, but it cannot create new patterns by itself. But this was the I mean to say this laid the fundamental of the modern artificial intelligence. Using this concept of the Hopfield network,
Was
here
it
comes
because
another.
was it because he was able to create a noise?
He was not able to create the noise, sir, but actually this Hopfield network can store the memories, just store the memories, and it can recall whenever it is needed. It cannot create new patterns or it cannot suggest new ideas. Hopfield network can just store the memories. But something more was needed, and this becomes possible using this concept of Boltzmann machine. With this picture, I would like to tell, I would like to make everyone understand that if if an expert musician is given some cue, no doubt this musician can recall the complete music, the complete pattern of the music. He can play the music, and even he can create new patterns. And it is exactly like the Boltzmann machine. The concept of Boltzmann machine was further told by Jeffrey Hinton, the next laureates who received the prize money of Nobel Prize. He suggested the base of the Boltzmann machine, the network which can which can create new patterns, having some distorted or noisy input. With the help of the distorted and noisy inputs, Boltzmann machine can create new patterns, new ideas, and it opens the door of the future also. This machine, uh, this machine, Boltzmann, in 1982, Hopfield suggested this idea of Hopfield network, and further using the concept of Hopfield network, Jeffrey Hinton suggested the concept of Boltzmann and restricted Boltzmann machine. This was the next picture I was about to show. Here, we can see the picture. The neurons are connecting each other with the help of the synapses between, it means the connection between them. And similarly, Hopfield suggested that the atoms in crystal, they also can interact with each other using the concept of atomic spin. And using this connection, the memories can be stored. The memory cannot be stored in a single atom or the single node, or similarly, it cannot be stored in a single neuron, but it's the connection between the neurons, that they are synapses in which the memories are stored. Next, here in this slide, we can see every data in the lattice can restore its place exactly as we can see here in the picture. If we drop a ball, it automatically searches the place where it is stable. In case of the gravitational field, if we drop a ball, automatically it comes down, and it finds itself the local minima, the place of local minima. Similarly, the memory is also stored in the local minima in case of the crystal lattice. And the picture here, you can see the input pattern. That means the noisy pattern of the letter J is shown. Whenever needed, this pattern can be recalled using the Hopfield network, and the sharp pattern of J is shown here. Uh, Now, in this picture, it's trying to show the concept of the Boltzmann machine and the restricted Boltzmann machine. In the Boltzmann machine, the nodes in same layer, they are interconnected, and not in not only they can store the older memories, but they can even create the patterns for the future uses, whatever maybe in use. And moreover, using the concept of restricted Boltzmann machine, the nodes in same layer, they are not directly connected, but the nodes in the hidden layers and the node in the visible layers, they are interconnected, giving the restricted Boltzmann machine the opportunity to perform the concept of machine learning even more better situation. So using these two concepts of the Hopfield network and the restricted Boltzmann machine, the machine learning is executed, the concept of machine learning is executed. I would like to now share this general applications which are being used using the concept of machine learning nowadays. We, in our phone or in our devices, we use the Google Photos, Spotify, Netflix, and different apps like Amazon, Duolingo, Uber, Google Maps, and whatever these are written here, Amazon, Flipkart, Misho, Siri, Google. Google Photos, they use the concept of machine learning to memorize the faces of the people and categorize them in a single group. Spotify is an app with using which we can listen different music, and once if a if a customer uses a music based on his interest, another music is automatically shown in front of him or his, whatever the music he likes, he can play in the next queue. Netflix similarly is an app which can be used in the television for the entertainment. If we watch a movie based on the same concept, another suggestion for the another movies are also reflected there in the television. If we use Amazon app, we purchase some item there based on the interest, another items are automatically shown there using the concept of machine learning. Similarly, Duolingo, if we install the app Duolingo, we try to learn some language there based on the previous uses. Again, the further suggestions are also shown automatically. Uber we use regularly. Uber, Ola, these all are the apps which we use to travel whenever we are not having our own vehicles. Once a ride is taken using the Uber, automatically suggestions are given wherever we need to go. Similarly, Google Maps, when we once we search the place, it automatically get stored there in the app, and based on the history, it suggests where you may go in future. It automatically starts suggesting. Similarly, Amazon, Flipkart, Misho, these all are the different apps using which we can purchase items, and based on the previous history, it automatically starts showing the suggestions which we can purchase in future using this here. Another apps, Siri, Google Assistants, we all use them in our devices. YouTube, Instagram, Facebook, these are the social media. Once we see any of the content in these out any one of the social media, automatically start suggesting different contents based on the previous history using the concept of machine learning. Similarly, Chat GPT, Gemini AI, these all are using nowadays the concept of machine learning. Here, it is the practical implications of the Atmanirbhar Bharat mission using the concept of machine learning in India. These all are showing the Indian apps, the names which I used in the previous slide. They were they were globally, they were getting used globally, but these apps are the really Indian made apps. We can see the Aratai. Aratai is recently created app which is being parallelly used with the WhatsApp, means it exactly works as the WhatsApp works, and this is created by the Zoho company. Similarly, Geo app, agio.com, Tata Neo, Rapido, which we use frequently nowadays, IRCTC app, which we use to book our tickets for the journey. AstroTalk, nowadays it is also in fashion. People are downloading these apps frequently as to talk different astrologers. And once if an astro if a customer talks to an astrologer, automatically it starts suggesting different astrologers with whom he or she can be connected, means a customer can be connected. Similarly, nowadays these Grow app and many more apps like this, which are being used frequently in India. This is Indian app. Grow and many more like such apps are being used for the financial management by the individuals. Blinkit app is there. Blinkit app, it is also being used very frequently nowadays. Persons can, means individual can order any item and it can deliver the items within 10 minutes or 20 minutes to our houses. So these all are apps using the concept of machine learning and helping for the humankinds. They are helping the person to save their time. In the next slide, the most important slides are here. uh, Now, Uttar Pradesh is going to set Lucknow as the first AI city in India. It's about to invest 10,730 crore rupees to develop this city, and it's going to use a flagship initiative of India, that is AI Pragya, and over 10 lakh youths, teachers, Gram Pradhan, government employees, and farmers are being trained in AI, machine learning, data analytics, and cyber security in partnership with the tech giants like Microsoft, Intel, Google. These giants are also going to help in this initiative, and this is really a moment of proud for all of us. Next, so overall, if we see, the machine learning is helping nowadays in different sectors like healthcare, finance, marketing and advertising, autonomous vehicles, retail, education, cybersecurity, entertainment, agriculture, transport. These all are the diverse areas, diverse sectors in which the concept of machine learning are really helping the humankinds. In the healthcare, now we can see many operations are being executed using the machine learning. Like if we go for the eye surgery, the machines are automatically executing the eye surgery. In case of finance, the app which I used in the last slide, Grow app, and many other apps like that, those are automatically using the concept of uh, the stop loss and trigger selling, so that the finance can be easily managed. In case of marketing and advertising, also autonomous vehicles. So though it is not very much possible to create autonomous vehicles, but the companies and different engineers are working their best to create autonomous vehicles, so that in future we can even travel without using a driver. We can drive different places very easily. In case of retails, in case of education also, machine learning is taking place. In case of education, students are using different apps, different platforms for the education, and based on their interest in which classes they are studying, automatically the different courses are suggested, they are popped up in front of them, so that they can opt out the so they can opt out the required one. In cyber security also, nowadays different apps are being created to avoid the phishing. entertainment, as we discussed in the last previous slides. In case of in field of entertainment, different apps are also there which are using machine learning. Agriculture nowadays, in agriculture also we are using the drones. It can automatically spread the required minerals. Using the drone, it can split, it can just it's, this optimizes crop yields through precision farming, monitor crop health using drones and sensors. Transportation, it is also being widely used. So these all are the discussions which I was to tell here, sir. And I would just thank you everyone for listening these all statements, these concepts, and letting me show these all slides. Thank you, sir.
Thank you, Prashant Shukla, sir. You did
Thank
a
you, sir.
good job, and perhaps
I,
you have given a thoughtful
I
window
would,
for students and everyone who has joined us, right? Now, I would
sir,
like to,
Malvi, sir, I think
yes,
we would first invite Rajiv, sir, to give him valuable comments on the theme and the sub-theme of today's lecture.
yes,
Then
I'm
we would
going
just
to.
receive the questions.
Okay, I'm going to invite our guest for speaking. But before that, I want to tell something about our distinguished guest. He has a very accomplished academic line, and Dr. Singh did his integrated PhD from the Institute of Mathematical Sciences, Chennai, from 2006 to 13. He went on for doctoral fellowship from Max Planck Institute for the Physics of Complex System from Dresden, Germany. Another postdoctoral fellowship. People do one, he has done twice postdoctoral fellowship. So he did another postdoctoral fellowship from Berlin University, Ramat Gan, Israel. And he has been a Ramanujan Fellow in Department of Physics, IIT BHU. And he took the charge of assistant professor in IIT department from 2017 onward. His domain of interest in research is quantum computing and machine learning, implementation and analysis of quantum algorithms, quantum and hybrid devices, modeling and programming of quantum devices, nanomagnetism and cavity magnonics, magnon photon interaction. So many physics involved in that. He will be the right person to talk about these terms. So I invite our chief guest, Dr. Rajiv Singh, for his talk. Over to you, sir.
Thank you, everyone, for your kind invitation. And I am really happy to see almost 100 people here on Saturday evening at 6:30, taking out time from whatever else they might be doing on a weekend. And I would like to also, no, I really appreciate the um, effort of the visionary president of the school about having this theme and motivating students to seriously think about research as a career, because for a country like us, it is really a need of the hour now. As if you follow international politics closely, you may see that we occasionally come across difficulties. For example, right now we are having some difficulties with US and other superpowers. And technology, so we have to be self-reliant in technology. Okay, so students are really, they are the future, and we would want to do everything ourselves. Okay, all the technological things. Now, coming to the theme of Atmanirbhar Bharat, and particularly today's session, which was on Nobel Prize Physics of last year on machine learning. Uh, Machine learning, as you can probably guess, machine learning or artificial intelligence, it's a sub branch of computer science. And I hope most students are nowadays do many courses in computer science, or they are familiar quite well with computer science, the subject and algorithms and logic, etc. in school. So The way this subject started, I want to just make some comment, is that if you have done any programming, you would see that it's very structured set of rules which we write in some programming language. I don't know what is taught nowadays, but probably something like C++ or Python. And then it tries to solve a problem. Define a problem. There is a solution also which you know, but executing the solution is difficult. So we write a computer program which will implement that solution. Now, when these people, these giants who won the Nobel Prize, when they were doing this particular work for which they got Nobel Prize, they realized that, okay, so this is one way we are developing the computers, but this is not the way nature has solved the problem of being intelligent. Okay, so if we look at a human person or many animals also, there is no, most of the time, there is no well-defined rule to tackle a problem. And that is why it is important that if a problem is presented which is new, in the sense that we have not seen anything like that before, using our experience, we are still able to think of a solution. Okay, so machine learning. So coming back to the machine learning or artificial intelligence, motivated by structure of the brain, it's a class of algorithm where the solution itself is not encoded, but the capacity to learn and develop a solution, the capacity itself is part of the algorithm. Okay, so so this we have seen for a long time, because sometimes when you go to you're browsing a website, suddenly a pop-up will come which will ask you that, which will try to verify whether you're a human or a robot, and it will show you a bunch of pictures and ask a question that identify traffic light or identify a car or something like that. So what is it doing? People had realized early on that identifying an image, especially when there is noise, some blurriness, etc., is a difficult computer problem. Humans are good at it. If you show a picture of any, let us say, handwritten word, so teachers have to do it all the time. If a student has very bad handwriting, you are still able to read most of the time what has been written. Okay, so even in the presence of bad handwriting, you can do that. So it is like very distorted way he's writing, but because you have seen so many ways of writing, let us say English or Hindi, you are able to identify that, okay, he is writing this particular thing. So this is one aspect, that this is what that CAPTCHA or this verify whether you are not a robot is trying to do. It is posing a difficult problem, which is difficult for computer. It is relatively easy for humans. Now, students here, they are very young, so they may have come across this thing for a very short time. People who are older, they would remember that this CAPTCHA or this particular process has very different now compared to what it was, let us say, 10 years ago. 10 years ago, very simple pictures were part of this. But in modern times, very complicated pictures are there with so much noise that many times even a human person is not able to identify what is written there, what is there. Okay, so what is the reason? Because the robots or whatever the software which is trying to imitate the human, it has become so advanced that the CAPTCHA problem of 10 years ago has now become easy for it. Okay, so there are different parts to machine learning. One is that you show a picture and ask what is written in that picture. Let us say the word A. So someone has handwritten A. See, typed letters are easy to read because they are very, they are much nicer and there is not so much variation. But if you ask a class to write the letter A, and there are 100 students, you will get 100 different ways of writing A. And then the algorithm has to realize or build into it all these ways and identify them as A. This was a contribution of Hopfield. He figured out his network of computer algorithm, which of course is very complicated. So at this level, we cannot have a technical discussion. But the essence was that Hopfield wrote a program to which if you showed a lot of patterns, it could save all those patterns. And then when you showed it new pattern, which was of similar type, but it had seen before, it would still be able to identify it. Okay, the task we do, let us say in in machine learning and AI and those kind of identifying a pattern, this kind of thing. Now, humans in particular are, and hopefully animals as well, because we are not so different. Only the complexity of task is different. We are not only able to do this one task which computers are bad at, we are also able to generate new content, a new picture, a new story, a new poem, okay, a new music, all forms of art. All right. Now, for a long time, people thought that coming was with something new is really, it is very uniquely human. And this idea has been challenged in recent times with softwares like ChatGPT. Okay, you can ask ChatGPT to make a painting, and it would come up with a painting, and you would be completely shocked that how how you give it a specification that I want to have a tree, I want to have this thing, etc. All this detail you give, and it is able to come up with a new, completely new painting. Of course, based on its experience, the way it has been trained. Now, this is where Boltzmann machine part is there. That it's also there is some similarity to Hopfield network, but it is a new concept where it is not trying to learn. This is called generative machine learning. It's not trying to learn from patterns. It's not trying to learn to identify patterns, but you show it 100 ways of writing A, and it will show you another 100 ways of writing, which is different from the previous 100. Okay, so it is so it can come up with new things. Okay, humans do this, no? Because if you look at let us say any form of art, you can see that over the time there are great artists who are born who will come and make an original new contribution to that particular art. Okay, so even computers slowly are reaching that level. They are in, then we have machine learning. So this is just these are some examples where how these two contributions won the Nobel Prize last year. One was the Hopfield network, the development of the Hopfield network, which was trying to identify a pattern, and the other one was the Boltzmann machine, which, as I said, that can generate a new pattern. And the motivation, to some degree, was how a human brain works. And I think one very remarkable, one thing which is challenging even today is that, and there is a long way to go forward in terms of research, is that, okay, nowadays computers are very, so if you are using ChatGPT and it looks very sophisticated, etc., you must remember that there is a huge computer somewhere, a very large computer system, a supercomputer, etc., which is doing that. Okay, which is running that algorithm and doing that. Whereas a human brain consumes a power which is less than 100 watts. Okay, so in olden days, a fan, let us say 2 fans. Working with the power of 2 fans, a human brain still can, at some difficult tasks, outperform a machine. Okay, so machines still have a long way to go before they are able to come up with some before they are really competitive. And so this was the development. This is really remarkable. And as Prashant was presenting, if we look at the range of application machine learning has entered, nowadays you cannot talk about any technology which does not use machine learning. Okay, you just name, so from driving your car to mobile phone, obviously. So you can say so some of you may have used. So there are now the software, for example, if you're on iPhone, there is an assistant. You can talk to your iPhone. You can give a command by speaking to your phone. Now, what is going on? You speak something, the speaker of the mic of the phone is recording that audio. That audio is processed, and they are able to identify exactly what you are saying. Okay, it is a more difficult thing than giving a command by typing, because there nothing has to be identified. Here, even if, so the point is that, and you may have, I don't know whether you have experience or not, but you will realize that if you get a new device, in the beginning it will make a lot of errors in identifying your command. But as time goes on, it actually learns how you say a particular word. And over time, so this is actually a real life example of interacting with the AI. Okay, when you're voice command to any computer, it is identifying how you speak certain words. And even if you speak them mistake, in a very peculiar way, which is not standard, over time it will be able to learn. Okay. So and and many examples. So all the recommendation system. So for example, if you watch a movie, then the software of, suppose you are on some app, let us say YouTube. What YouTube will do, everyone who liked that movie, it will browse through the database and figure out what are the similar movies which they liked, which you have not watched. That it will give you as a recommendation. Okay. So in modern times, for example, even simple thing like a Google search, it is very subjective in the sense that it is very personalized. Your Google search will look different from your friend's Google search because Google is machine learning to all the things you have done in the past. Okay. So they keep track of what your interest is, what kind of things you like, what kind of things you don't like. And when you make a simple search, it takes that into account. And your friend who has a very different thinking and very different ways of interacting with the machine, your search result may be completely different from his. Okay, so things are highly personalized now, and it of course has. So these are some common examples, and it of course has applications in any, even from very serious things like medicine. Okay, so for example, routinely what happens is, there is a lot of shortage of good doctors in the world, and we would like, but the task they do is somewhat routine. Of course, expert knowledge is needed, but doctor's time is way valuable for him to do that by himself all the time. So people are developing software where you can just feed in an image of, let us say, some diagnosis, some test which was done, let us say, some
Rajiv
X-ray or
sir,
something.
sorry for interruption. Rajiv sir, sorry for interruption. So 1 minute for you to conclude. Next, we will have to move for a question and answer round. So 1 more minute, you can go ahead.
Sure, sure. So, for example, so I was giving the example of medical diagnosis. So you feed in image of some test which was done like X-ray, and looking at a database of such things, a computer will automatically try to figure out what the problem was, and most of the time it will get it right. But the point is that this will save the time of the doctor who would have to do it manually by himself. And as Prashant was mentioning in the presentation, India is serious about all these applications. And as an example, he was pointing out that already the government of UP and government of India, they have identified Lucknow where to become the first AI city. So a lot of research which is driven by AI or machine learning is a very high priority of the government. They want to make the Indian population well educated, very competent in usage of AI. And I hope that many of the students here, they would also take up this challenge and make fundamental contributions and develop really good solutions to practical problems which we face as a country, based on modern technologies like AI and other things. So I will stop here and thank you for inviting me.
Thanks a lot, Rajiv sir, for your wonderful, really insightful words and the way you have explained this thing. And what about the what opportunities we have in India, especially what youngsters can go ahead with this concept. Yes, a lot of challenges are there in this field, and the machine cannot outsmart human. The precision human mind has, machine cannot do that. Is still the point you said about. I would like audience to raise a few questions. If you have, you can text your question in the text box so that we can pick up and discuss them.
I have a comment.
Yes, sir, go ahead.
This is wonderful. This lecture turned out to be the way I wanted. And I appreciate Prashant and Dr. Singh. But I bring a different perspective to this whole intelligence. I am a doctor. I am an endocrinologist. and I'm a good one. So I was telling Prashant Malvi, he has a 3.5-year-old daughter. So I told him, all the new cells for the brain are built by the body by the age of 18 months. After that, no new cells are made. The intelligence comes along as you connect different neurons with dendrites and axons. So more exposure you give, the more intelligent you become. If you want to be a Koop Mandoop, just look at the sky above the well. And if you want to be very intelligent, be exposing yourself. Open all the windows of the mind. Let all the knowledge come, and the brain will process it. But I want to warn these students who are here in the audience, your job right now is to master mathematics, master physics, master the fundamentals of the knowledge which you are being told. Don't jump into artificial intelligence and find your answers, because I'm in America and I see here that they're using it for finding answers to your questions, the homework. Don't do that. Your job right now is to master the fundamentals. And I will, I can keep talking about this, but I want to request Dr. Singh to open the door for our children, our students, to come to his department and come to us. Punaragamanaya. Please come back. You are a very inspiring person. Now, the questions could be followed. Thank you.
Ajay sir, do we have any questions? If you can see in the chat box.
आप पढ़ के सुनाइए उनको
No,
क्वेश्चन
no,
अगर है
sir.
No, there is no questions they have raised.
Okay. All right.
So-
Let me speak a little bit more, couple of minutes. We are using many things in our school. Our biometric signing recognizes your face and it puts you in. I use ChatPad a lot, quite a bit when I create new documents. When I run into a question, how can a teacher teach better physics or better math? I ask the AI and it comes up with the answers. So I will defer now to Mr. Tiwari to move the vote of thanks. If there is any question any student has.
One question.
Go ahead.
I just want, can AI or this can replace the technology, can replace the teachers?
Well, we have different videos they produce. Okay, you can watch a lecture and all this. So that's all AI. When I started the computer first time in my practice, all I knew that it can store knowledge and it can categorize it. That's all. That's what the computer was doing way back. But now it's doing all the things which you have expressed here and shown in the slides. I have used, I would say, 99% of all the things which you have shown, and we have to improve on that. So I will stop here. Mr. Tiwari?
Yes, sir. Can I go ahead?
Yes.
Yes, I request our principal sir to please move vote of thanks. Really a very approachable, empathetic, visionary, and disciplined person. So I invite our principal sir. Over to you, sir.
Okay. Thank you, Mr. Malvi, for giving me this opportunity to offer my vote of thanks. Good evening, everyone. It has been such an honor to be the part of this wonderful event, Atmanirbhar Bharat lecture series. On behalf of my school, I would like to extend my heartfelt thanks to Dr. Rajiv Singh, Assistant Professor, IIT BHU, and our the respected President, Sir, Dr. Suman Kumar Misra. I would also offer my heartfelt thanks to my PGT, Mr. Prashant Shukla, who was presenting this lecture series. I would also like to offer my wordful thanks to my all entire IMS team members and those who are on this platform to hear us. Definitely, this series, I hope, definitely was very wonderful and beneficial for you all. Thank you.